Hi guys, welcome back to my channel. So in this video I'm going to show you how to find the maximum or the minimum value of a directional derivative. Alright, so we are given a function over here and we have to find, let's say we're finding the maximum value first. Okay, so max value of this function at this given point. Okay, so to find the maximum value, the formula is we have to find the gradient of the vector first and then we have to norm the vector. So this is the formula to find the maximum value. So I hope you guys remember how to take the gradient. If you don't, then I have already explained how to find the gradient and I have made a video on that, and the link to that video will be shown in the I button, so you can click that out and check that video. It's also listed in the description below. Alright, so let's get started. So first we're finding the gradient of this vector of this function. So since it's a 3-variable function, first we have to find the partial derivative of this with respect to x, and then we have to find the partial derivative of this with respect to y, and at the end we're finding the partial derivative with respect to z. Because it's x, y, z, it's a 3-variable function, so first we differentiate with respect to x, then y, then z. Alright, so first we are differentiating with respect to x. That means the other variables are treated as constants since it's a partial derivative, right? Okay, so we're only differentiating x and y and z are held constant. Okay, so differentiating only x, this gives us 1, so we don't write it, and then this is a constant, so we leave it over here, and then this we leave it over here. These are constant, and then of course we're differentiating x, so that becomes an 8 if we bring the 2 down. Okay, so let me write it neatly. So 8, we bring the 2 down, so that 8x. Okay, that's 0 because it's a constant. Now I'm differentiating with respect to y, which means x and z are held as constant. Okay, so this is constant, we don't differentiate it, the y squared, and we're differentiating y, treating x as a constant. Alright, let me do it real quick. Okay, I hope you guys understood. Okay, now differentiating with respect to z, this is a constant, goes to 0, this is a constant, goes to 0, differentiating only z, so that's 2z. Okay, now once we have the partial derivative of all of them, we can write this all together. So how do we write this all together? We're going to write it in the form like I hat, g hat, and then k hat, right? This is how we write the gradient vector. Okay, so first we have the I hat, so this is our I hat. Okay, and this is our g hat, 2yx minus 4x squared. That's g hat. And then this is the k hat since it's in the z direction. So 2z k hat. So this is our gradient vector over here. And now, what was the formula to find the maximum value? We had to norm the gradient. But how can we norm this gradient? We need to first evaluate it at the given points. 1, negative 1, 2. Alright, so we'll plug in the point in this gradient. We are plugging in the 1, negative 1, and 2 in this equation. So this is x, this is y, and this is z. So this is y, right? So we're plugging negative 1 first. So negative 1 squared times 8 times negative 1 times x, which is 1. This is our I hat. And then 2 times what? This is y, that's negative 1. And then 1 minus 4 times 1 g hat plus 2 times 2 k hat, and this gives us, if you calculate all this, so this should give you f is equals to 9 I hat, negative 6 j hat, positive 4 k hat. And now we can find the gradient of this vector to find the maximum value, right? So that's the formula to finding the maximum value, and we need to norm it. So how do we norm it? So we are going to square each component and then square root the whole thing. Alright, squaring each component will give us 9 squared, 6 squared, 4 squared and then square rooting the whole thing, which is of course 81, 36, 16 square. So this is going to give you 133 square. So this is the maximum value. But what if I tell you to calculate the minimum value as well? So how are you going to calculate the minimum value? That's correct. You're simply going to put a negative in front. Okay, so this is going to be your minimum value. So what do you find for the maximum value? You just put a negative in front. That would be a minimum value. So let me write the general formula over here. So this is to find the maximum value, and this is to find the minimum value. I hope you guys find this video helpful, and thanks for watching. Bye.